So this is Algebra 1, Lesson 2 point, what? 9, Day 2. Okay? Yesterday we were talking about weighted averages. We did a little bit of mixture problems with mixing types of coffee or things that had a price attached to it. Yes? Today we're going to talk about things that don't have a price, they have a percentage attached to it. The cool thing about percentage ones, the table or the chart we're going to fill in is slightly smaller than it was yesterday. Because the percentage as a name, we can easily convert that to a decimal to use it. Okay? So we need to still, okay, we'll read the problem first before we build the chart, but we will have to build a chart and fill it in. So, it says Mr. K has 16 cups of punch that is 3% pineapple juice. He also has a punch that is 33% pineapple juice. How many cups of a 33% punch will be needed to add to the 3% punch to obtain a punch that is 20%? Okay, remember what we talked about yesterday. We talked about yesterday that when you take two things and put them together, they start to go towards each other, right? As in their values. So, in this particular problem, percentages. So 3% put in, 33% in, the resulting will be somewhere in the middle. You guys agree with this? If I put something in that's really expensive, and I put something in that's really cheap, the result will be someplace in the middle of those. That's what we did yesterday, right? The middle price, the one that we were trying to make, was somewhere in the middle. We also talked about yesterday that the one where our result is closest to is the one we had to use more of. So 20% is closer to what? 3 or 33? It's closer to 33. So in our minds, we should automatically know that I'll have to use more of the 33% than the 3%. It's got more weight. Weighted averages, guys. So I'm going to make a table. And like I was saying earlier, that our table only has 3 columns this time. Because the percentage itself is going to be a label, but I also know in my mind that 3% is what is a decimal. 0.03. 33% is 0.33. So we don't have to make a separate column to label it as the decimal form of a percent. Okay? So, same rules apply. The same rules apply as in the first column, you put your labels in. What goes in are the top two. What results is the bottom one. What are we mixing together? What are we mixing? Types of juice, the concentrations. What concentrations? 3%, 33%. I should result, after putting these together, to get what? No, it's not going to be a 36%. It can't be. It's going to be a 20%. That brings up a good point, guys, that it was said to be 36%. If I start with a concentration of a certain level, adding something that has a lesser level of it will never result in a bigger concentration. It's hard to come up with a situation that doesn't actually involve like a problem like this. It's not like I'm taking the number of gallons of something plus another gallons of something to get more gallons, right? When I put them together. That's not what we're doing here. We're equalizing things together. Right, there you go. Taking high pulp orange juice, low pulp orange juice to get someplace in the middle. Some pulp, right? High pulp with no pulp gives you some pulp. Yes, they do. I'd rather have it. I like to chew my orange juice, so I get high pulp. So, also, since we're talking about juice here, hey guys, it's a really funny story. You know that they sell juice. Sometimes it says juice. And sometimes it says, oh, 100% juice. Yes?
Real juice.
Real juice. Now, if you guys have any of these things at home that says 100% real juice, they come in flavors of cranberry, they come in flavors of grape and everything else, right?
Yep.
Cherry. Take a look at the number one ingredient
Sugar.
on your 100% juice.
Sugar.
Even though it's not going to be this. Most of the time, your number one ingredient is apple juice.
Really?
Your number one ingredient will be apple juice, but yet you're drinking grape juice.
It's apple juice just pop grapefruit.
They just put the grape flavor takes over
grape
the
sugar.
flavor, so therefore
Wait,
they
so it's
cut
all-
the cost by making it with apple juice.
Is all it's apple juice or just flavor?
Just enough for lying to you.
No, because they're not. It's 100% juice. Apple juice is a juice. So therefore, they're fine.
It's like a
Interesting, guys, isn't it? But anyways, let's go back to our problem.
Everybody just said.
So is everybody okay with the fact that if I mix a 3% and a 33%, it will result with something closer to the middle or someplace in the middle between those two ranges?
Yeah.
Our particular problem, it is 20. Now, the next line, or the next column, has to be something about that juice. We know something about a juice. We have cups of juice. So therefore, this is what it's going to be. Cups of juice. And do we know any of these particularly, how much we have? One of these we do. What is it?
16 cups of sugar.
16 cups of the 3% juice. Now, this is actually kind of interesting. Hey guys, for Halloween, I took all my kids' candy, laid it out, okay? And say that I found, well, I'm getting there. I found, let's just say there were 100 pieces of candy. I know that would be really off the mark, okay? But say there's 100 pieces of candy. And I told you 25% of them were Kit Kats. How many Kit Kats do I have?
25.
Or the kids have? They have 25 Kit Kats. If I said there were 15 Kit Kat, or 15% of those 100 are Kit Kats, then what would it be? 15. So we're saying that if I take the percent of something times the amount of candy there is, it'll tell me how many of them are only Kit Kats, or that particular candy. You guys can agree with that? No different here with the juice. So if I take 16 cups of some juice, it happens to be 3%. If I multiply those two together, so I get 0.03 times 16, I will end up with what? Get your calculator out. 0.48 cups of what? Not juice anymore, a certain type of juice. Pineapple juice. Guys, just like the candy idea, there was 25 Kit Kats. Just Kit Kats. This time, I have 3% of 16 cups, 3% of the 16 cups of juice is 0.48 cups of pure 100% pineapple juice. So if I was somehow to be able to distill or take out the pineapple juice of those 16 cups, I would only have less than half of a cup of pineapple juice. The rest of it would be water, some other juice, something, right? You guys agree with this? You guys can kind of picture this?
Yeah.
Now, if I did the same thing with finding how much 33% was, and I said, hey, I know this, what would have to be true about these two columns and the final one? Here. They have to equal each other. Because the amount of pineapple juice in one juice added to the pineapple juice in the other juice will have to equal the amount of pineapple juice in the whole entire mix. Think of it this way, guys. I bought a bag of Skittles. I bought 2 bags of Skittles. There were 25 green ones in the first bag and 36 green ones in the second bag. If I put them all into a bowl, how many green ones do I have? 25 plus 36, right?
That's 61.
Okay? Does it change the fact that there's still the same amount of green ones? whether I put it together or not. Yeah. Same thing happens here with the juice. The amount of pineapple juice that's present in the first mixture plus the second one will have to equal the total juice container, right? The only problem is, how much 33% do you have? First of all, isn't that the question?
Yes.
And if you don't know what it is, what do we call it? X.
X factor.
Wait a minute. We also talked yesterday that when I have this chart, I do what going across?
No, multiply.
Multiply. So therefore, this will become 0.33x. That's how much juice I have, or pineapple juice, that I have of 33%. When we're going down, we're going to add. Yes. But we still need to, that means, I guess, that's going to help us with the amount of cups of juice. How much juice of 20% do I have then? Yeah, it's x plus 16. Because whatever it is, if those 5 cups of 33, I would have to add it to 16, right? Is everybody okay with that? And then I multiply across again. 0.2 times x plus 16. Oh, you multiply going across. We're going to add going down. So here's the thing, guys. So that means 0.48 plus the amount of juice in the second juice will have to equal the amount of juice in the whole entire juice mixture. Can you guys solve that? I would hope so. What do I have to do with the 0.2? Distribute 0.48 plus 0.33x equals 0.2x plus what's 0.2 times 16? What's 16 times 2? Move the decimal place once. Should be 3.2, yeah? And now, solve for x. What's smaller, 0.48 or 0.2? So subtract 0.2x. And since I'm bringing all the, whoa, careful, wrong spot, huh?
Yeah.
Okay. Since I'm moving the x's to the left, that means I want to get the numbers to the right. So can I subtract 0.48 from both sides? These are gone. These are gone. I need to go over on the side here. What is 0.33 minus 0.2? 0.13. X equals 272. And we could solve for x. We just have to by 0.13. Now, before we actually give a number, what do we know that this number actually will have to be? No, don't tell me an answer yet. What do you think? What predictions? What is it going to be more than? From what we talked about before we even started this problem. You think it's going to be bigger than 40. How did you come up with that idea?
Is that right?
40 is, I think, a little too much. Monica? No? Guys, more than 16.
Yeah.
How did you figure that out?
I just looked at the cups of 3%.
What did we say then in the very beginning? Which one are you going to have more of? The 33%. If you have 16 cups of 3%, you know for sure, 100%, that you have to have more than 16 cups to make it go towards 33. So what is the actual answer? 29 to cups of 33%. Do we have more than 16 cups? Yes, so that should this make sense? Yeah. We talked about this, guys, but I forgot this would be cups of pure pineapple juice, right? Cups of pineapple juice. Forgot to state that. We've talked about it, but I forgot to write it down. Okay, one type of antifreeze is 40% glycol, and another type of antifreeze is 60% glycol. How much of each kind should be used to make 100 gallons of antifreeze that is 48% glycol? I'm going to give glycol as a type of alcohol that is actually found in your antifreeze in your car.
Isn't it freeze?
It will be a very low freezing temp. So that's what, and boiling temp. So it keeps your car from overheating or freezing. Guys, I'm giving you guys a couple minutes. Set the table up. The table looks really close to the last one. And then we're going to come together to fix it. If we need to. So, guys, this one's a fun one because it changed up the order of things on us. We know that I am putting a 40% in, yes? And a 60%. And remember, the one you're creating always has to go in the bottom. 48%. Question, in the long run, we'll know we're going to use more of what? The 40%. Because it's closer to 40 than it is 60. Guys, need to kind of realize that. We also were told there's 100 gallons that they have to have. Let's just assume, guys, the container only holds 100 gallons. Can I add 75 and 50? No, it'd be overflowing, not a good idea. So, if I said there was 20 gallons of the 40, you didn't say, how many gallons of 60? 80. If there was 50, then it would be 50-50. Hey, but if it was 50-50, then you would be right down in the middle and you'd be at 50%. Does everybody kind of see that? If you had the same amount of each, you just average the two of them together. But, so you know you're going to have more than 50 gallons of that 40%. Can you guys kind of visualize that as well? So, I don't know this. No, this was, wait, gallons, right? Gallons of antifreeze. I don't know that. I'm going to call it X. We've always been calling our unknowns X, right? But how many of us right now say, I don't know 60 as well, I want to call that a Y. But here's the problem. If I introduce an X and a Y, I'll have two variables. I don't want two variables. So how can I link the 60% with the fact that I have an X and a 100? What's true about this system?
100 minus x.
It's 100 minus X. How did you figure that out, Cheryl?
Because
Please share with us.
x plus x equals 100.
X plus 100 minus X will equal 100. I can only fill it 100 gallons. Guys, when I said if there was 20 in the top, you told me I would have to have 80 for 60, right?
Yes.
You got that because you took 100 and minus 20. If I said it was 50, 100 minus 50 is 50. If I say, hey, it's X, then you say it's 100 minus X. Guys, the rules still apply. When adding, when you go down, or when you're going across, you will,
What?
when going across,
Yeah, you multiply.
multiply. So, 0.4x. Wait, what is that column going to be? Gallons of glycol. Pure 100% glycol alcohol.
Glycol.
That sounds
No drugs in school.
You wouldn't want to drink that.
good.
That would make you sick and die.
So would
Bleach.
marijuana.
Oh, no. What?
Is that bleach? No. Glycol is not a bleach. Bleach is not an alcohol. Okay. Next one, guys. 0.6 times 100 minus x. And the last one is 0.48 times 100, which then equals 48. We could do that without a calculator. That's nice. Anytime I can just kind of clean things up, we'll do that. Yes? So what's true about all of this then? Give me the equation, guys. 0.4x plus 0.6 times 100 minus x equals 48. Yes, just distribute the 0.6. You guys seen? Whoops, that's not negative. That it's not too bad. What's 0.6 times 100? 60 minus 0.6x equals 48. Oh, this is kind of cool. I actually don't have to bring the x's over. They're already there. What's 0.4x minus 0.6x? Put these together.
Wait, no, I said that.
Negative 0.2x plus 60 equals 48. Oh, Mr. Konchak, I don't like negative values on my variables. That's okay, though. Because I'm going to subtract 60, and when I subtract 60, what happens on that side? That's also negative, so it's a negative 0.2x equals a negative 12. Divide by negative 0.2. Negative negatives make a, and 12 divided by 0.2. 60. 60 what? Gallons? No, not of glycol. Of
40% glycol.
40%
48%.
glycol. Does that answer our question?
No.
No, it does not answer our question because the question is saying how much of each kind. We got one, so if there's 60 of one, the other one will be 40 gallons of 60% glycol. Boom. Guys? Okay, your homework then is just on more of the same type of problems. On page 136, this is day 2, guys. Put day 2 on there. This is page 136, 6, 9, and 10. Have a great weekend.